We are now ready for part 4 of our absolute value lesson, real-world situations. The first thing we're going to do is check our answers from part 3 with comparing and ordering absolute value. Have your answers ready to check. I have all of the answers up for you instead of going through them one by one. In blue, I have the values of each side when we're comparing, and then in red I have our symbol greater than, less than, or equal to. And then at the bottom, from least to greatest is the first one, and greatest to least is the second one. Go ahead and pause the video now and check your answers. How can we use absolute value in everyday life when talking about elevation, direction, and distance? When measuring the distance between two values, one lying above 0 and one lying below 0, we take the absolute value of each and then we add those values together. In the diagram below, we represent Mount McKinley as 20,230 feet and Death Valley as a negative 282 feet. But to determine the distance between, we have to take the absolute values of each and then add the values together. So we are wanting to know the distance between Death Valley and Mount McKinley. Mount McKinley is 20,320 feet from 0. Death Valley is 282 feet from 0. It's going in a negative direction. It's below sea level. Mount McKinley is above sea level. It's a positive direction. If we take the absolute value of Mount McKinley, because the absolute value is the distance from 0 to the number, and we take the absolute value of Death Valley, because the distance is 0 to the number, and we add those two absolute values together, we will find the distance between Mount McKinley and Death Valley. So our problem would be the absolute value of 20,320 plus the absolute value of negative 282. This would be the distance from this point to this point, and from this point to this point. When you take the absolute value of 20,320, we get 20,320. When we take the absolute value of negative 282, we get a positive 282. So we're adding these values together, and our answer would be 20,602 feet. That's how far apart they are from each other. The following table shows the weight change from 2005 to 2007 for 4 different women. Kate in 2005 weighed 93 pounds. In 2007, she weighed 88 pounds. If you subtract these two, 93 minus 88, you get 5. Since she went down in weight, our change would be a negative 5. With Maddie, she went from 77 pounds to 74 pounds. If you subtract these two, you get 3 pounds, and that's a change of a negative 3 because she went down 3 pounds. Tess went from 99 to 100. If you subtract these two, you get 1. However, she gained weight, so that would be a positive 1. Anna went from 91 pounds to 95 pounds, and if you subtract these two, you get 4. However, she went up in weight as well, so she gained 4 pounds, so that would be a positive 4. To find the change in their weight, if you look at the absolute value of each of these numbers in red, which is what we're going to do, and then we can answer our question about the change in their weights. So the absolute value of a negative 5 is 5. The absolute value of negative 3 is 3. The absolute value of a positive 1 is 1. And the absolute value of a positive 4 is 4. Now our question reads, Which woman had the greatest change in weight from 2005 to 2007? Well, the one that had the biggest change in weight was Kate. Although she lost 5 pounds, it was still the biggest change when you look at the absolute value. She has the greatest absolute value. Which woman had the least change in weight from 2005 to 2007? Well, the least amount, if you look at your absolute values, would be Tess. Even though Tess gained weight, she still had the least amount of change. This example is on your handout at the very top of the page. It says Amy dove in the pool 6.5 feet. Then she came up 4.2 feet before swimming back down 5.8 feet. She swam back up 7.3 feet. What is the total distance that she swam? Write the problem using absolute value notation. So we're going to go back and look at the problem, and we need to write it in absolute value notation. So my first key words here is that Amy dove in the pool 6.5 feet. If she dives in the pool, that would be a negative integer. So I'm going to write the absolute value of negative 6.5. Then she came up 4.2 feet. Okay, she came up. That's a positive integer. Now I'm going to add all of my absolute values together. So I'm going to put a plus sign in between all of these. Since she came up 4.2 feet, that's a positive 4.2. So I write that the absolute value of 4.2. Then she swam back down 5.8 feet. So that would be a negative 5.8. So I'm going to add the absolute value of negative 5.8. And then she swam back up 7.3 feet. So I'm going to add 7.3, the absolute value of 7.3, because she swam up, and that would be a positive integer. Once you have your absolute value notation problem written out, you're going to find the absolute value of each of these. The absolute value of negative 6.5 is 6.5. The absolute value of 4.2 is 4.2. Plus the absolute value of negative 5.8 is 5.8. And the absolute value of 7.3 is 7.3. You will add all of these values together to see how much the distance that she swam. So when you add all of these together, she swam 23.8 feet. So let's look at number 1 on your handout. It says Billy the bird is flying 724 feet in the air, while Freddie the fish is swimming 236 feet below sea level. How far apart are Billy and Freddie? Well, if you have sea level and Billy the bird is flying 724 feet in the air, so that distance is from 0 to 724, a positive distance. If you have Freddie the fish, who is 236 feet below sea level, that would be a negative 236 if you wrote the integer. So we want to know the distance from negative 236 to 0. So you're going to take the absolute value of both of these numbers, and then you're going to add them together to get the distance between Billy and Freddie. So we would have the absolute value of 724 plus the absolute value of a negative 236. The values of both of these are positive, so you have 724 plus 236. So the distance between Billy the bird and Freddie the fish is 960 feet. Let's look at number 2 on your paper. John's kite flew 117 feet in the air. It then descended 45 feet before rising 60 feet. It then fell 100 feet and landed into a tree. How many feet did the kite travel? So the first thing we're going to look at is the absolute value of 117. This is a positive 117 because it's up in the air. It went up in the air. So you have the absolute value of a positive 117. It then descended 45 feet. Well, descend means it's a negative term, so we're going to add the absolute value of a negative 45. And then it rose 60 feet. So we're going to add the absolute value of a positive 60. It then fell 100 feet and it landed into a tree. So we're going to add the absolute value of a negative 100 because it fell. If it falls, that's a negative integer. Then we're going to take the absolute value of each of these numbers, which they are all positive numbers when you take the absolute value, and we're going to add these together to see how far the kite traveled. When you add them together, you get 322 feet. Okay, let's look at number 3. In the morning, the temperature was 12.6 below zero. In the afternoon, it was 7.9 degrees above zero. How much did the temperature change? I would like for you to write the problem using absolute value notation and then the answer. Go ahead and pause the video now and work the problem and then come back. Your problem should have been the absolute value of negative 12.6 plus the absolute value of 7.9. You would find the values of both of these, which is 12.6 plus 7.9, and the temperature change was 20.5 degrees. Number 4, the roller coaster ascends 40.5 feet above the ground. The wave pool was 12.75 feet deep. How far is it from the top of the roller coaster to the bottom of the wave pool? I would like for you to write the problem in absolute value notation and then write your answer. Go ahead and pause the video, and then once you have your answer, come back to the video to check. Our problem would be the absolute value of 40.5 plus the absolute value of negative 12.75. We are going to find the value of both of those. So you add 40.5 plus 12.75 together, and you get 53.25 feet. This would be the distance from the bottom of the wave pool to the top of the roller coaster. You are now ready to go to the next step of the learning path for a short review and then to take a formative quiz.